So in the previous session, we clearly discussed how can we modify an element in the linear single linked list. So linear single linked list is over. Now, in today's session, I want to talk about how can we create the circular single linked list. Okay. So what is the topic name here? Topic name is, just a minute. Please wait. Just a minute. Okay. See here. So now topic name is creating circular single linked list. Creating circular single linked list. So you already know about linear single linked list. In the linear single linked list, last node's next value is what? Null. Last node's next value is null. In the linear single linked list, last node, this is the last node. After this, no node is there. So last node's next value is what? Null. So this is linear single linked list. Whereas in the circular single linked list, now I'm opening circular single linked list. Observe. See here. So this is the circular single linked list. In the circular single linked list, last node's next value is first node, first address. So this first node's address we are maintaining in the last node. Means last node's next node is what? First. Means this is becoming circular now. So last's next node is what now? First. So this is becoming circular. I want to create this circular single linked list now. So you already know how can we create the linear single linked list. So just instead of holding null here, we hold first node's address. So in the last next we holds first node's address. This is the only difference between circular single linked list and linear single linked list. In the linear single linked list, last node's next value is null. In the circular single linked list, last node's next value is first node's address. So this first node's address we are maintaining as the last next here. So first is becoming last next node. That is circular single linked list. I want to create this one. So for this, first we have to make the plan. That plan is nothing but class. So which classes we have to define? So we want to create the nodes. So define one node type class. So define a node type class. So which properties we want? Observe. So which properties we want? In the node, to hold the data, take X. To hold the address of next node, take pointer variable next. We want to hold address. So take pointer variable. So I want to create integer circular single linked list. So int X node next. I want to hold address of next node. So node type pointer variable I'm taking here. So this is the class we have to define. So define a class with the node name. So with the two properties, X and pointer next. Define them in the public section. Define another class. I'm giving class name as C linked list. Okay. So to hold first node, take first property. To hold last node, take last property. To create temporary node, temp. To access the nodes, take pointer. So I'm taking four properties here. First, last, temp, pointer. Okay. Then define one constructor to initialize the object. So class name is and constructor name should be same. So take C linked list as the constructor name. Define the constructor. Okay. Then to print all elements, define show method here. To add the nodes, to add the element, define add method. To count number of elements, I'm taking one count variable here. So this count extra I'm adding. Okay, for the linear linked list, we didn't count the number of nodes, but now I'm counting number of nodes. So to count number of nodes, I'm taking count variable here, count property. So these two classes now we have to define. This is our task. So define a class node, define a class C linked list. Okay, so finally from the main, in the main create object of the C linked list, add the nodes by calling add method, add 5 nodes, print those 5 elements. That's it. That is our task. So now we have to define how many classes now? Two classes. Two classes we have to define. So now I'm opening developer C++, observe developer C++. See here, I'm opening a new source file here, new source file. Define a class with the name node. First class I'm defining. Node class I'm defining. Just now we created a plan. I'm following this plan. So I have to hold data, take X variable, to hold address, take next variable. Define it. Okay. So define them in the public section. Define them in the public section. Okay. I want to access them outside of the class. So define them as the in the public section. Okay. So int X node next. So this is the class. Define another class. I'm giving class name as C link list. C link list. C link list is the class name. Just a minute. Yes. C link list is the class name. Starting point of class, ending point of class. Class terminates with semicolon. Define the properties here. I'm defining some properties here to hold first node's address. I'm defining node type pointer variable, pointer first, to hold first node's address. To hold last node's address, I'm taking another variable, another pointer variable, last. To hold temporary node's address, pointer temp. To access the elements, I'm taking one pointer variable, ptr. So then define the constructor in the public section. So constructor name and class name should be same. So write C linked list. So initially there is no first, there is no last, right? Initially there is no first, there is no last. So first value is null and last value is also null. First value null and the last value is null. Initially no nodes are there. So when we create the object, the constructor will be called. Where we create the object in the main. See here. Observe carefully. Observe carefully. So where we create the object in the main. Okay. So what's the class name? C linked list. So to the C linked list class, we create the object. So C linked list L1. C linked list L1 is the object name. So L1 object is created. So when we create the L1 object, this constructor will be called. So when this constructor is called, first value will become null, last value will become null. So first value, last value both are same. So you can write like this. You can write last equals to first equals to null. Last equals to first equals to null. So with this what happens? Null value will be assigned to the first value will be assigned to the last. So first value will become null value and last value will become null value. So first is null, last is null. To count the number of nodes, I'm taking one variable, count variable here, int count. To count the number of nodes I'm taking. So initially no nodes are there. So initially count value is what? 0. So initially count value is 0. Initially no nodes are there. So to count the number of nodes, I'm taking count variable. Initially no nodes are there. So count value is 0. Number of nodes value is 0. Okay. Now I want to add the nodes. So I want to add the nodes. I want to add the elements. So for that, I'm defining add method. So we give the value which we want to store in the node. I don't want to return any value. So return type as white. Right? Return type as white. Okay. So we call like this. Here we call L1 dot add of. We pass the element 10. So first time we are calling. So now with this statement, what happens? This add method will be called. Now we want to create a node. We want to create one node. Okay. So we want to create a node like this. We want to create a node like this. So to create a node, create object of node class. Create object of node class. So here this one is the X, this one is the X, this one is the next. I want to create this object now. This node object I want to create. So to create node object, create object of this class node. So if you create object for this node class, to hold X value, memory will be allocated. To hold next value, memory will be allocated. So we want to create this object. So to create this object, here we want to hold X value, here we want to hold next value. To create this object, create object for the class node. Okay, so dynamic object I want to create now. So to create the dynamic object, we use a new keyword. So write new node here. So with this new node will be created. Memory will be allocated. New means memory will be allocated. To hold x value, memory allocated. To hold next value, memory allocated. So one node is created. This node's address I am holding in the variable temp. So I am assuming this node as temp now. So this is the temp node. So now temp node is created. This is the temp node. Temp node is created. Okay, this temp x value. This temp x value. Okay, we are passing here when we are calling add. When we are calling add method, we are passing value as 10. So now what is the v value now? V value is what? 10. Now v value is 10. So this is temp x. This one is temp x. In the temp x, I want to store this value 10. So 10 is the v value. So in the temp x, I want to store v value. So what we write? Temp x equals to v. Temp x equals to v. So with this here, 10 value will be stored. Here, 10 value will be stored. 10 value will be stored. Okay. After this, what I'm doing is, after this, what I'm doing is, see, observe carefully. So one temp node is created. One temp node is created. One temp node is created. Okay. So we have to check whether it is first node or not. So to check whether it is first node or not, I'm checking the condition as first equals to null. So when this linked list object is created, at the time this constructor is called. So initially first value is null, last value is null. Now what is the current first value? Null. What is the current last value? Null. Now first value is null, last value is null. So first value is null. So this condition is true. So when this condition is true, that comes into this block that executes this code. So now we have to read the code. So which code we have to execute now? If this is the first node, first equals to null means if first equals to null, if first value is null, make this temp node as the first node. So now this make this node as the first node. So no nodes are there. First value is null. No nodes are there. Just now we have created one node. Make this as the first node. That's it. So make temp node as the first node now. So make this temp node as the first node. Okay. And make this temp as the last node. Now this one is the first node. This one is the last node. This one is the first node. This one is the last node. Okay. So we have to write like this. To make temp as the first node, we write first equals to temp. Okay. To make first as the last node, right? Last equals to first we write. So with this temp node's address will come into the first node's address will come into the last. So now temp is the first, temp is the last. First is the last means first means what? Temp only. So this temp is the first, temp is the last. Now this one is the first, this one is the last. Now this temp node is the first, this temp node is the last. This one is the first, this one is the last. Now first value is not null, first has this node's address. Last value is not null, last has this temp node's address. Okay. So instead of writing two different statements, you can write like this: last equals to first equals to temp. Now temp is becoming first, first is becoming last. Now temp is the first node, this temp is the last node. Okay. So after that, last nodes next node value. Okay. In the circular single linked list, last nodes next node holds first node's address, right? Last node's next node holds first node's address. So write last next equals to first. Last next equals to first. So here I am writing last next equals to first. That's it. Last next equals to first. So this first is becoming last node's next node. So here this first node's address will come. So now in this example, now this one is the first node, this one is the last node. So last node's next value also this first node's address only. Okay, because this is circular single linked list. So this value is also first node's address only. So here also it holds if first node's address is 1000, that 1000 value will be stored in the last next. So here that holds first node's address only. Okay, so here we are holding. So here we are holding first node's address. Last next, we are making last next as the first node. So last node's next node is what now? First node. Okay, so for that we are writing this last next equals to first. Okay, I want to count the number of nodes. So after adding the node, we have to count it. So initially count value is 0. So to count it, write count to plus plus. Count to plus plus means one value of count will be increased. So you call add method, you are calling add method for one time means count value will become 1. This is the code to add a node. After adding, it is counting. Okay, so else. So if this is not first node, if this is first node, execute this code. Okay. If this is not first node, which code we have to execute? Observe. So again, we have to create another node. So I'm calling like this. So one node is created. Okay. So now this one is the temp. This one is the first. This one is the last. So last node's next value is first. So this is holding this node's address only. In this next, this is holding this node's address only because this one is the first. This one is the last. Okay. Now I'm adding one more node here. L1 dot add of 20. So again, we are calling which method? Add method. But now what's the v value now? V value is not 10 now. V value is 20. So again, we have to create one more node. So this new node means one node will be created. New node code will get executed. So a new node will be created here. A new node will be created. In this node, to hold the x value, memory will be allocated. To hold the next value, some memory will be allocated. So this one is the x, this one is the next. So memory is allocated. So this memory location's address will be given to the temp. So this new node is created. New node means new node is created. So this new node's address will be given to the temp. So now this becomes the temp node. If this is becoming temp node means now this one is not temp. This one is not temp. Okay. Next. Next. So temp node is created. Temp x equals to v. So what is the v value? 20. So the 20 value will be stored in the temp x. So temp x value will become 20 now. Value is stored. Okay. Now it checks whether it is first node or not. Now it checks whether it is first node or not. So now what is the first value? First has first node's address. So first has this node's address. First is pointing to this node. So this node's address is in the first. So first value is not null. So this if condition is false. So that comes to the else part now. So now we are not inserting first node. So that comes to the else part. So now this first value is not null. First has this node's address. So some address equals to null. Condition becomes false. That comes to else block. Okay. Now which code we have to execute? So make this temp as the last node's next node. Means we have to establish a link like this. Observe. We have to establish a link like this. Okay. Just a minute. So we have to establish a link like this. This link I want to establish now. So this temp node's address we want to hold in the last next. Last next. So last next, make temp as the last next node. So for that, right here, last next equals to temp. So this temp node's address will come into the last next. So now this link is created. This link is created. Okay. So this link is created now. This link is created. So this temp node's address is in the last next. Okay. Link is created. Okay. So this is becoming last next node. So now this temp should become the last node. So make this temp as the last node. Now this one is not last node. Now this one is not last node. Make this as the last node. Make this as the last node. Okay, make temp as the last node. So to make temp as the last node, okay, what we write here? Last equals to temp. Last equals to temp. So now temp becomes the last node. Now this one is not last node. This one is not last node. This temp is becoming the last node. Okay. So after that, this code will get executed. Last next equals to first. So this first node's address will come into the last next. Means this link, I'm drawing the link. So this link will be established. So last next is pointing to the first node. Last next holds first node. So circular single link list created. In the last next, we are holding first node's address. Okay. So this link created now. This link created. So last next has first node's address. Circular linked list created. Now count value will become what now? 2. Count value is 2. So 2 nodes are there. Similarly, last time I'm explaining, I want to add one more node. Observe, I want to add one more node. Observe carefully. L1 dot add of, I'm giving value as 30. So now which method we are calling? Add method we are calling. We are passing value as 30. So what's the V value now? 30. So with this statement, observe carefully. With this statement, a new node will be created. New node means new node will be created. Here, new node will be created. In this new node, to hold the X value, some memory will be allocated. And to hold the next value, some memory will be allocated. So this is the X, this is the next. So node is created. Okay. So this node's address will be given to the temp. This node's address will be given to the temp. Okay. So now this is the temp. This node's address is in the temp. So now temp is pointing to this node. So now this one is not temp. This one is not temp. This one is temp now. So temp x value, v value. Temp x equals to v. So now what is the v value? 30. So this value will become 30. This value will become 30. Okay, now it checks whether it is first node or not. First has this node's address. So this is not first node. So comes to the else block. Last next equals to temp. Okay, so this temp node's address, this temp node's address will be stored in the last next. So now last next has first node's address actually. So make this temp as the last node's next node. So make temp as the last node's next node. Okay, means this link will be gone now. This link will be gone. This link will be gone. Okay, this temp will become last node's next node. This temp will become last node's next node. Now this link is not there. This link is not there. This link is not there. So this link established now. So temp is becoming last node's next node. So last next, in the last next, that is storing temp node's address. So this is pointing to this temp. So last next is holding temp node's address. So this link is established. Okay, then last equals to temp. So this temp becomes the last node. So now this temp becomes the last node now. So now this one becomes the last node. Okay, now this is last node means this one is not last node. This is not last node. Now this is the last node. So now observe here. Next, after this code will get executed. Last next equals to first. So this is last. Last next holds first node's address. So in the last next points to the first node. So this link will be established. So last next pointing to the first node. This link established. Okay, circular linked list created. So last next has first node's address. So for that we are writing this statement. Now count value will become 3. Third node. Count value will become 3. So hence we can add a node to the linked list. I hope you understood. So linked list is created now. So similarly, I want to add 2 more elements. L1 dot add 40. Temp node will be created. Okay, that becomes last next node, and temp becomes last node, and in the last next that holds first node's address. That's it. Very simple. Okay, next I want to print all these linked list elements. For that I want to define one show method now. Now define one show method here. Define one show method. So right here void show. Void show. Starting point of show, ending point of show. Okay, here observe carefully. I want to print this linked list is already created. This linked list is created now. Now I'm clearing all blanks because you already know how can we create the linked list. So this linked list is created now. This circular linked list is created. Circular single linked list is created now. I want to print the elements. So this circular single linked list is created. I want to print the elements now. Just a minute. Okay, so this is the circular single linked list I want to print. So assume this first node as the pointer. Assume this first node as the pointer. Just a minute. Assume this first node as the first node as the pointer. Assume first node as the pointer. Okay. So for that, what we write? Pointer equals to first. Pointer equals to first. This pointer variable already we declared. Pointer variable already we declared here. Okay, PTR pointer variable we already we declared. Okay, so PTR equals to first. So now we are assuming first node as the pointer. So if this is pointer, this one is the pointer next. Okay, so now I want to print this x value. So this is the x, this one is what? Next. I want to print this x value. So we're assuming first as the pointer. So to access this 10 value, I want to access this 10 value. So we are assuming this first node as the pointer. So pointer has first node's address. Pointer x we write. Pointer x. So C out pointer x means 10 will be printed. So I'm writing C out pointer x. C out pointer x. So pointer value is first. So first x. So first element 10 will be printed now. 10 will be printed. After that, I want to print 20. So to print 20, so now this one is a pointer. This one is a pointer. This one is pointer next. So make pointer next as a pointer now. Now right now this one is the point. This one is the x. This one is the next. So this is x. This is next. So to access this 20 again write pointer x only. Okay, so make pointers next as a pointer. So to make pointers next as a pointer, write pointer equals to pointer next. So pointer next becomes a pointer now. So now again pointer x means 20 will be printed. So this code we have to execute repeatedly. So next make this pointer next as the pointer. Now this is the pointer next. Make this pointer next as the pointer. Okay, make this pointer next as a pointer. Make this pointer next as a pointer. Print the element. So we are assuming this as the pointer x 10 will be printed. So next we are making pointer next as a pointer x means 20 will be printed. Next we are making pointer next as a pointer x means 30 will be printed. Next we are making pointer next as a pointer x means 40 will be printed. Next we are making pointer next as a pointer x means 50 will be printed. So 5 times we have to execute. So in the linear single linked list we have written condition as pointer next equals to null. Pointer next not if pointer not equals to null, so this pointer next is becoming the pointer, right? So pointer next, if this pointer next will become the pointer, so after this no node is there, so pointer value is null. So null not equals to null condition false, then the terminates the loop in the linear single linked list. But in the circular single linked list, pointer next has some address. So pointer next equals to first. So this first node's address will come into the pointer. So again all the elements will be accessed. Circular. So again 10 will be accessed. So that's why what I did is I counted number of nodes here. I counted number of nodes. So to count number of nodes, we have taken count variable. Initially count value is 0. After adding the node, we are counting here. So finally number of nodes value is in the count variable. So if 5 elements are there, 5 times we have to execute this code. So number of nodes value is in the count. So I'm writing int I equals to 1, I less than or equals to count. So if count value is 5, 5 times the code will get executed. So if 5 nodes are there, count value will be 5. So 5 times code will be executed. So 5 elements values will be printed. Count value 10 means 10 nodes are there. So 10 times this code will get executed. Okay. So count is the number of nodes value. If 5 elements are there, 5 times this code will get executed. So 5 elements will be printed. That's it. So in the linear single linked list, so at certain stage pointer will becoming null. Pointer next is we are making as pointer next we are making as pointer. At certain stage pointer value is becoming null not equals to null, condition becomes false. But here pointer next is becoming pointer, but its value will not become null because pointer next is holding first node's address. So if we write pointer x, it will access this first element again. So because it is circular, so that's why we are counting number of nodes here. So those many times we are printing. So if count value is 5 means 5 times this code will get executed, means 5 elements values will be printed. So that's why we are counting number of nodes. That's it. Okay. So this is the code to create linear single linked list. Now observe. Okay. So now it will give some errors. Observe. I'm pressing F11. Save it. Save it in our folder. Our folder is in the D drive. CPP DS coed is our folder. Okay, so C linked list 1. I'm giving file name as C linked list 1.cpp. Save it. So it is giving some errors. Observe. So that is not finding where is this null. That is not finding where is this null. So null defined in the IO stream header file. So we must write hash include IO stream, and cout is defined in the cout is declared in the std namespace. So we must write using namespace std, using namespace std. Press F11. Observe the output. Now it is printing the elements. See here. So 10, 20, 30, 40, 50 created, printed. So circular linked list is created. Elements are 10, 20, 30, 40, 50. I hope you understood. So very clearly I explained. So it is same as linear single linked list. Just we are holding first node's address in the last node. So to hold first node's address in the last node, so we are writing last next equals to first. So we are making first node as the last next node. So last node's next node is first. We are making last node's next node as the first node. That's it. And here we are counting number of nodes. So to count number of nodes, I'm taking count value as 0. After adding a node, this is the code to add the node. After adding the node, we are counting it. So if one node is added, count value will become 1. If 5 nodes are added, count value will become 5. So 5 elements values I want to print. So 5 times I want to execute the code. So this code I'm writing. So this count refers to number of elements, number of nodes. So first time pointer value is first. So first X will be printed. So next pointer next will become the pointer. So now pointer value is first next. So first next X means the second element. Second value will be printed. So like this it executes for count number of times. So if count value is 5, 5 times it executes. So 5 elements will be printed. So 5 elements are printed. Observe here. So 10, 20, 30, 40, 50. So hence we can create the circular single linked list. Now I'm stopping the session here.